Okay, today we are going to speak about many-to-many relationships in DAX. First of all, who am I? I'm Alberto Ferrari. I'm a consultant, supposedly a BA expert. I work on problem solving, complex project assistance, and data warehouses on both UDM, multidimensional, we cannot call it UDM anymore, multidimensional, and now in tabular. I work for SQL BI, which is a branch of a Microsoft BI Gold Partner on BI and databases. I'm also a book author, a SAS maestro, and as you have already heard, I speak a strong spaghetti English, so get prepared to it. I can help it, so if you don't understand, just raise your hand and say, repeat it in English, please, and I will try to do that. The agenda. We are going to speak about many-to-many relationship, only many-to-many relationship and their implementation in DAX. We will start speaking about the data model of many-to-many relationship and then look at the DAX Formula pattern, so how to use many-to-many relationship in a very basic way. Since the formula is very, very short and very, very complex to follow, we will speak a bit about how it works, why it works, how the engine solves every step to solve the many-to-many, and then after we have good insights on how many-to-many relationship can be made to work with DAX, we will use that pattern to solve several problems, several scenarios. We will see the cascading many-to-many scenario, then the survey data model solved with many-to-many, basket analysis, and at the end, SQL 2012, Denali, that has some news for many-to-many. That means Denali does not handle many-to-many as the Vertipaq 1.0 does, but there are some features that might be useful for many-to-many relationships. For the ones of you, just a quick survey. How many of you have read the Many-to-Many Revolution, the first version for UDM? Well, more than half, so you know everything about many-to-many. And how many of you have a good understanding of what many-to-many relationships are? Wow, that's perfect. For the ones of you who already know the many-to-many revolution, and for the ones who want to learn about many-to-many in UDM, we have finished writing a new version of the white paper that now contains both multidimensional and tabular. So many-to-many, a deep dive on many-to-many on both flavors of data modeling available in SQL 2012. It's not yet available because in theory it should have been available a few hours ago, but you know we are Italian, and so it's not yet available. But if you subscribe to the newsletter, we will warn you as soon as we are able to make the website come up. That said, a few words about expectation. I will use, but I'm not going to explain tabular basics, DAX basics, how evaluation contexts, what are evaluation contexts in DAX and how they interact with relationships, and of course data modeling with many-to-many. So the last question before I start is, how many of you have a basic knowledge of DAX? Everybody. Wow, that's my session. I love you. So let's start without any other, let's not waste time. This is the pattern we are going to use. This is a current accounts data model with many-to-many. You know, if you have a current account, you open it on a bank, and you can share it with your wife, with your girlfriend, with your friend, with anybody else. So a single current account is shared by many people. Thus, each transaction is tied to one account, but that account, through a bridge account customer, is then tied to DIM customers. So there is a many-to-many relationship between customers and account, because many customers can have more than one account. And of course, a single customer might have more than one account. So this is the classical data structure where many-to-many are useful. There is no easy way to solve this scenario using a simple star schema, because of course each transaction has an amount, and that amount cannot be split among the different customers. So we need many-to-many. In tabular, there is no support for many-to-many, and this is the sad fact of life. Multidimensional has the many-to-many kind of relationship. You can use many-to-many. You can have dimensions and create a bridge table inside and have the many-to-many relationship, which are hard to use, but they can be done. The model support many-to-many. In multidimensional, there is no support at all for many-to-many. Multidimensional only supports simple plain vanilla relationship one-to-many, and that's all you can do out of the box with tabular. Thus, we have two options. We stop here, we go to it something, or we start using DAX and discover how we can leverage DAX and relationships to emulate many-to-many relationship, to compute the many-to-many inside DAX formulas. First of all, I'm going to show you some demo, just one demo. And before I show you, none of my demo will make you say, whoa. Or what you will say is, oh, yes, it works. It can be made to work. So my demo will be very fast, just to show you that the formulas compute something. After that, we have to go a deep dive inside the formula to understand how it works. So let's start with the first one, that is the classical many-to-many pattern. Here we have once power pivot starts. Okay. Our data model, we have the table, the bridge table, account, customer, date, the type of transaction, and finally, the fact table containing the transaction. If we go to the Power Pivot window, we can use the diagrammatic view to see how the relationships are set up. Okay, the wonderful diagrammatic view that is available in SQL 2012. And you can see that we have the fact table here, dimension containing account, and then the bridge table and the dim customer. Okay? This is the data model that we are going to query. Sorry. If we use this data model and we put, for example, the account on the rows and then the customer name, and from the transaction we simply put the amount, you see that the numbers are not very interesting because they repeat the same value each time. Just because many-to-many relationships are not working, we are not able to set up any many-to-many relationship there, and this formula simply does not work. In order to make it work, we need to create a new formula, a new measure. This is amount M2M corrected, because of course there is the wrong one we will discuss. Using that measure, many-to-many will start working. And you see that they are working, looking. This is the name of the account. Mark Paul is an account. Mark is a customer. Paul is a customer. 1,000 is in charge of Paul, a Mark. But the sum of both is still 1,000, because many-to-many, of course, is a non-additive measure. Okay? Thus, our goal is that of writing this amount M2M correct and understand how it works. Let's go back to slides and try to understand how to make this formula work. In order to use the many-to-many, you need to understand how calculate works. How many of you have a good knowledge about calculate? Well, everybody. That's fun. That's interesting. Row context, filter context, and the most important fact, the fact that calculate transforms an eventually existing row context into a filter context. And since filter context do follow relationship, we will use that feature to make many-to-many works. In the next slide, we'll take a look at the formula. It's not important to understand it now. Just look at it, memorize it, and try to have a good, make a photo of it. So this is the formula. Whenever I have a many-to-many, in some way I have to fall in this pattern. The amount M2M is computed using calculate, sum of fact transaction amount, and then the red part is a filter that makes the magic, that makes many-to-many work. Okay? have a look at it, and then we try to understand how the formula works, what we need to do looking at the data model. We have this data model, and we know that there is a filter on customer, because my user takes the customer, puts it on the slicer, and decides to filter all data for a single customer. So the filter starts on dim customer. What we need to do is to move the filter to dim account, because of course dim customer is not linked to the fact table. So we are not going, if we put a filter on customer, the fact table is still free. It does not sense any kind of filter. On the other hand, if we put a filter on dim account, since there is a direct relationship between the fact table and the dim account, then the filter will work and the fact table will get filtered. But what we need to do is to move the filter from dim customer to dim account. And this is where our formula starts to work. Once dim account is filtered, then dim account will filter, due to the direct relationship with the fact table. So the task that we are going to perform is moving the filter from dim customer to dim account. Once we have done it, the formula will start working. That is the formula. The filter part is the one that we are going to try to make it work. Let's see what happens when the formula works. The first filter is applied directly by the tabular data model, because in Excel we have a filter, we have a slicer, then we put a filter. So we do not worry about dim customer. It gets filtered by the user, by Excel, by some kind of query. But then we have the red part, this filter over dim account. Filter is an iterator. So it iterates over all the rows inside dim account, and for each of these rows, it computes calculate. What calculate does is counting the number of rows that are still visible in the bridge table and check if the number of rows in the bridge table is greater or less than 0. In reality, it is greater or 0. If it is greater than 0, then that dim account survives the filter. Otherwise, it doesn't work. So once what calculate does, it uses the bridge to push the filter up to dim account. And finally, what we do, once we have filtered the dim account table, we compute the sum fact transaction amount that is computed in a filter that makes visible only the row in dim account that survive the filter. Now, how many of you have understood all what I have said? How many of you did not understood? Okay, there's always the null answer, and it's very hard to understand the difference between who got and who did, who doesn't. Anyway, let's try to understand it better and to give a meaning of the complete formula. The naive error, the classical error that everybody starting from me does when creating many-to-many is forgetting to write calculate. You see in that slide we have amount M2M correct and the same amount wrong. The wrong one does not contain calculate. It just count rows. And you see in the yellow highlighted cells the difference between the two formulas. Amount M2M wrong always compute the grand total at the customer level, while the amount M2M correct computes the correct value whenever we are on a customer. And in order to understand well how the formula works, it is better if we start trying to understand how the wrong formula behaves and why the wrong formula always computes the grand total. So let's take a look at the data. We start with this set of data. We have the customers, the bridge table in the middle, and the account table on the other side. And we have the user that selects poll and want to see the amount that is available to poll. Since there is a selection on Paul, cross-filtering is applied to all the rows in the bridge table that are in relationship with Paul. So we set a filter on customer, and this filter is propagated to the bridge table automatically by the Vertipaq engine just because we have created a filter on Paul. And now our formula starts to work. It's amount M2M wrong. We do not have calculate, we just have count rows, bridge account customers. Okay? What is this formula going to do? We have an iterator, filter, over dim account. And this iterator will iterate over all the rows in the account table. For each of these rows, it will compute the count rows, bridge account customer. So, let's make it work. The first row is Mark. We are iterating over the rows inside our table. And we need to compute how many, we need to compute count rows bridge account customer. So we need to count the number of rows visible in the bridge table. How many rows are visible in the bridge table in this moment? 8, 2, let's make 0, 1, 2, raise your hand if you say 3, any number is fine. Okay. The problem is the number of rows visible is 2. Because nothing is happening. I'm just iterating over the account table. Nothing changes in the filters because I'm just iterating over the account table. And nowhere is written that iterating over the account table, there is a filter that should be applied on the bridge table. So 2 rows are visible when I'm iterating over Mark. Count rows will return 2. And at the end, count rows is greater than 0. Thus, filter will make Mark survive. Then we filter Paul. Nothing changes. Robert, Luke, Mark and Robert, and Mark and Paul. At the end of the iteration, all the rows survive the filter because I computed for 8 times, 6 times the value 2, which is the count rows of the bridge table. Okay? And this is the reason why if I don't put calculate before count rows, the formula doesn't work. If on the other side I use calculate, the behavior is somehow different. Let's look at it. We start with the same scenario. We select Paul. Paul cross-filters both Paul, Paul, and then Mark, Paul, and Mark, Paul. So this is identical before. The formula is different. Now we have calculate of the same expression. You should remember that calculate transforms any existing row context into a filter context. The row context does not propagate over relationships. This is one of the characteristics of the row context. The filter context propagates over relationships and cross-filters all the tables that are related to the table that contains a filter. Calculate transforms the row context into a filter context. So the row context does not interact with the relationship. The filter context does. So the transformation of the context will make the magic. We are going to iterate over our account table. We filter Mark, but before computing the count rows, the row context is transformed into a filter context, and only Mark, only the row containing Mark is cross-filtered. All the other rows are hidden. Okay? Now, how many rows are visible now in the bridge table? 0, 1. Who says 0? Who says 1? Somebody still says 1. Okay. 0 rows are visible because the previous row context, filter context made visible only Paul, Paul, and then Paul, Mark, Paul. Then we have a new filter context that makes visible only Mark. The intersection of both, of course, now is the empty set. Thus, count rows equals 0 now. And the result is that we discard this row. It's not, the count rows is equal to 0. Then we have Paul. Paul filters Paul. Now the intersection is 1 row. So count rows equals 1. And since count rows equals 1, Paul survives the filter. We make the same for Robert. We trash it. Luke, we can trash it. Mark Robert filters 2 rows. Nevertheless, the intersection is still the empty set. Thus, we trash him. Mark and Paul, the green part filters 2 rows. The red part filters only 1 row, but 1 row is still existing. So count rows equals 1. And at the end, once filter finished its work, the 2 rows, Paul and Mark Paul, are visible in the dim account table. We have pushed the filter from customers to accounts using the bridge table through the iterator. And now the filter is working on a dim account table. Since it is working here, now it is effective against the fact table. And the fact table fills the filter that starts from the customer and move to account. Okay? This is the reason why you always see the grand total with the wrong formula, and you see the right value with the correct formula. Okay? Everything's clear up to this point? Yes. To go to a conclusion for what is important for many-to-many, the big difference in many-to-many from UDM, from multidimensional to tabular, is that the complexity is no longer in the model, it's moved inside the formula. In multidimensional, if you have a data model containing many-to-many, you can set up a many-to-many relationship, and then that relationship will work against all the formulas that you can compute. In tabular, this is no longer the case. If you want to compute a measure that traverses the many-to-many relationship, you have to make the complexity inside the formula. If you have 50 measures, it means that you have to modify 50 measures so that many-to-many pattern works inside each of these measures. This is painful, but this is life. There's nothing that we can do to change the behavior. Nevertheless, if you have a good understanding of calculate and of how filter context and row context behave against relationship, then many-to-many can be made to work pretty easily. But this is just the beginning of the session. It was important to state how many-to-many works, because once you get the behavior of many-to-many, all the formulas are very easy to write. Before you get the correct behavior, they are really hard. I still remember when I first tried writing these formulas, I always try to write the formula, look at the result. If it was wrong, I try to surround it with calculate. If the value was correct, I say, okay, now it's working. I have no understanding about why it was working. Now, I have it. That's it. What happens if you have more than one many-to-many inside your data model? Cascading many-to-many is a very common pattern, and it happens when you have more than one many-to-many pattern before reaching your fact table. In this example, we have the first many-to-many pattern, identical to the first one, and the second one happens because a customer might have one or more categories. And the categories, of course, might have 0 or more customers. So there is a many-to-many relationship between customers and categories, and a many-to-many relationship between customers and account. And if I want to browse my transaction table filtering the category, of course, I need to apply the many-to-many pattern more than once. We start filtering dim category, and we need to push the filter on dim account. This time, we have to do the first step from category to customers. Once customers are filtered, we can do the second step and filter accounts based on customers. The pattern is identical to before. Of course, at the end, account will filter the fact table. The pattern is the same, but this time we need to jump 2 steps before we go to the final result. Okay? The demo. The cascading demo is, of course, very similar to before. We now have categories. Let's look at them in the Power Pivot window just to take a look at what categories are. One can be IT enthusiast, rally driver, or traveler, but of course, an IT enthusiast that is a rally driver and travels a lot has 3 categories at once. The rest of the data is identical before, and we want to get this result. We filter by category, and you see that Mark is an IT enthusiast. Robert is an IT enthusiast. But Robert is I have too many mouses here. Robert, who appears here, is even here, because he is both a rally driver and an IT enthusiast. And of course, the numbers should not be summed up all together to give you the result, but they should follow the many-to-many pattern. Okay? Cascading many-to-many are really easy to use and to understand, because you just need to write a formula that does 2 steps instead of doing only once. And the formula is here. It looks complicated. It's that huge calculate. Can you read it from the bottom? Yes? No? Somebody from the bottom that says I can read or no? Everything's fine. Good. Pardon? I have not understood, I'm sorry. This is in the middle? Then you have a problem. You can change your place. I'm not going to move that. So, we have 2 steps to traverse, and the first step is computed by the first part of the pattern. This is the pattern of many-to-many. It's a filter over a table where we iterate and compute account rows over the table. And so this part is the first filter. The second step is computed by the second filter. And it is worth noting that this filter happens before this one. This is very important. If you use calculate, sum, and then put both filters at the same level, they will get computed in parallel. They will not interact each other, and the formula will not work. You have to start from the farthest table, put the filter from DIN category, and push it to DIN customers. Once that filter has been correctly applied, then you can do the second calculate that will work with the first set of filters already in place. If you have 3 levels, 3 inner calculate. 4 levels, 4 calculate. 5 levels, you are in trouble. Maybe you might think about changing your data model because it's getting too complex. Nevertheless, the pattern is very easy. Just add 1 calculate each time is needed, and use always the same pattern. Okay? Cascading many-to-many have a generic formula. They work with any number of steps, just a matter of writing the formula. The only point where you need to be careful is that you always need to start from the farthest table and then move 1 step after the other through until you reach the fact table, and use 1 calculate for each step. The other point is that the complexity is geometric. Geometric? Geometric. Okay. The complexity is geometric. So if you have 1 million rows in the first bridge or 1 million rows in the second bridge, the multiplication of 1 million for 1 million makes a huge number that I don't know now. But if you have 3 level, 4 level, complexity is very easy to make. It's very easy that you get a complexity it is too high. And Power Pivot, Vertipaq as UDM will be very, very slow. There is an alternative that I'd like to show you about cascading many-to-many, that is to flatten the two bridge table inside 1 single table. This is the very same data model the very same data as before with a different data model. once I had two bridge tables, now I have created only one table, that is bridge account, customer, category. Of course, there is the need for some ETL there, because probably that table doesn't exist. But if you can materialize the relation, the two steps inside a single relationship, then life will be much easier, because you have a bridge table that now fills two different filters, one coming from category, the other one from customer. Both filters will work on the bridge table, and when you iterate over the bridge table to filter the dim account using the count rows, you will be able to use a single many-to-many to work on a cascading one. Of course, the bridge account customer category will be a bigger table, because it will be probably the multiplication of the two tables. Not exactly the multiplication, it depends on your data. It might be much smaller if your data do not contain all permutation of customers and categories. So it's worth trying this data model, because it performs faster, because the filtering of a single table, of course, it's faster. Even if the table is huge, filtering just one is much easier than iterating over to calculate in order to perform the final computation. Okay? Thus, when it's time to speak about cascading many-to-many, the flattened data model might be an option. It all depends from your data, but it's worth a try. It's faster than the cascading one. The formula is much simpler, but it needs some kind of ETL. And I suggest you to make a try in multidimensional too. If you have cascading many-to-many in multidimensional, either you read Marco's paper and you find the correct way of setting up the relationship in order to make everything work, or you do some ETL and you create a simpler data model that works with one single table. Okay? Yes, question?
How's performance-wise? Does it perform using formula?
It's faster. Oh, the question was, how about performance? Is it faster, and how much is faster? It's faster. I don't have precise number to tell you. I can tell you that it's faster. Normally, when the performance of many-to-many really depends only on the bridge table. So you can have thousands, millions, billions of rows in the fact table. Doesn't matter. This is not a problem. The only problem is the intermediate dimension. When you are in the range of some million rows, it still works very fast. If you have tens of millions, if you have hundreds of millions of rows in the bridge table, then you are in trouble. But it's the level that you can reach before having performance problem is much higher than in multidimensional. When you stop working in multidimensional because you say, okay, now the table is too big, I can no longer work with this data model, tabular has a lot of power to give you. I see that 5 million, 8 million, 10 million rows inside the bridge is not a problem. Yep.
Have you ever tried to do this ETL in Power Pivot instead of in an external tool like in Vertipaq SQL?
This ETL in Power Pivot? No, of course. The question, if I understood it well, is have you tried to do the ETL in Power Pivot to create the bridge table? The answer is no. Power Pivot has no ETL feature. So if you want to do ETL, you have to do that in SQL. What I have done is simply create a view that does a cross-join of the two tables and builds my bridge table. Yes?
When you bring your data in if you bring your data in from SQL, or if you're using a table connection to Excel, for instance, as long as all the data exists in that one data source, you can do your cross-join right in your select statement when it comes into Power Pivot.
Yeah. In fact, the question is, you can do ETL. You can use a query in Power Pivot in order to perform this type of ETL. It's exactly what I have done. It's not ETL. It's just a different way of loading data. And of course, a cross-join is fine. Yes?
Maybe it's a stupid question. If you go back much back, if there was a relation from the fact transaction to the bridge table on the ID account, I don't know if it's possible to have multiple relations
multiple relationships from the ID account.
If the ID account and the fact transaction will relate both to the DIM account and to the bridge account.
Okay. So the question is, why don't you create a relationship between the DIM account in fact transaction and the ID account in the bridge table? Is it?
Between the two, between the fact table and the fact list table.
Is true.
Yeah. Yes.
Okay. And the answer is no. You cannot create such a relationship because ID account is not a key in the bridge table. In the bridge table, the key is ID account, ID customer, ID category all together. So you cannot create a relationship between the fact table and the bridge because ID account is not a key for the bridge table. So you cannot create a relationship. Yes?
This technique can also be used in the direct query mode of tabular. There's no restriction right there.
So the question is, can we use this technique with direct query? That's interesting. I have not tried it. We have somebody here who might know the answer. Okay. That's the Microsoft answer. That means we haven't tried, but I see no reason why it shouldn't work. After all, customers are here so that can try our software. So what's the problem? So, let's move on. And yes?
So I'm wondering which of the tricks to optimize multidimensional many-to-many will apply. Like the whole signature dimension thing, find the accounts, find the customers that roll up into the same list of accounts. That would seem to help. What about partitioning the bridge table?
Yes, so the question is whether the tricks that we normally use in UDM to make many-to-many run faster are still useful here to make many-to-many run faster. The partitioning does not help in any way. Partition exists in tabular, but they are not related to performance. If you have a table with 100 partition, it will behave exactly as if you have one table containing all the partition in one single table. They are there just for management. So partitioning is not useful. Other tricks, any trick that reduces the size of the bridge table should help. But of course, you still need to balance between complex formulas and a small bridge table. In general, what I have seen is that tabular is amazingly faster if the formulas are pretty easy. If the formulas start to be complicated because they need to do some kind of consideration due to your tricks, then it might be a problem. Nevertheless, if you reduce the size of the bridge table, of course, you will greatly help performances. Okay? Let's move on. Another data model that might be implemented using many-to-many is the survey data model. Survey is very common. A lot of people use survey and has this simple data model. We have one fact table that contains answers and 2 dimensions split on 2 different tables each, customers split in categories, and then answer and question. We make question to customer, a question is related to an answer, and the customer gives us an answer. The fact table now is nothing but a very big bridge table between question and customers. If a customer answers a question, there is a row in the fact table. Of course, many answers have many customers answer many questions, and so we have the many-to-many structure here. The question we are going to pose to our system is, what is the yearly income of consultants? That translated in the survey data model means take all the customers who answer consultant a job question, so you get a list, a set of customers, and then slice this set of customers using the answer they gave to the question yearly income that has different kind of answers. The beauty of this data model is that the job the price, the income is not in the data model. The data model is very generic. It can contain any kind of question, any kind of answer, and we will be able to query it in a very generic way without having a specific data model for a specific question. As usual, let's take a look at the demo, which again is nothing very sexy. It just shows you some results. We have selected job. On the answer slicers, we have selected, we selected job. On the rows, we have the answer they gave us to job, which might be consultant, IT pro, or teacher. And then we selected yearly net income on this slicer. And here we have the different answers that the user gave to yearly net income if he is a consultant, an IT pro, and so on. One thing that is worth noticing is that slicers, even if they are working, that means I have selected yearly net income and I have selected job, are graying out everything. And the reason is that when many-to-many are there, the engine is not very good in understanding which row, which value is really working on the table. And the final result is just the number of people who answered to each question. The data is random generated, so of course we don't care about what is the real result that we are looking at. Okay? So we want to produce this workbook as our final result. First of all, the data model, the analytical data model that we are going to use is slightly different. As a first step, I have merged question and answers, customer and categories, so that I created a dimensional model. But then we need two filter dimensions because we are going to use two different questions for our data model. On the first table that I call filter 1, I will select as question 1 job and answer 1 consultant. So I will select only rows where filter 1 will contain this answer. On filter 2, I just select question 2 yearly income to see what are the different values for the answer on filter 2. In general, you have to create many filter dimensions for the number, one filter dimension for each question you want to put in the same pivot table for the same, for your data model. Okay? And this time, the bridge table is our fact table. So the data model is slightly different from before because now we are using the fact table as the bridge between two dimensions, and we will simply count the number of rows existing inside our answers table. Okay? The first problem that we need to solve is that this is our data model, and we cannot represent this data model inside tabular. The reason is that we cannot create the two relationships starting from answers and going to filter 1 and filter 2. Because we have only one column containing ID answers, and in Power Pivot 1, we can create only one relationship using ID answer. So we can create either the relationship with filter 1 or the one with filter 2, but we will not be able to create both relationships and make the system work. Okay? Thus, the first problem that we will have to solve is that the relationship is non-existent. We will need to work without that relationship. Nevertheless, we will need to push the filter on customers from the two tables. This is the formula. Let's spend a couple of minutes on it because it's interesting. And even if it seems very complicated, it is not. I haven't said anything funny, or I shouldn't have said anything funny. Remember the pattern of many-to-many. We are interested in searching inside this formula the pattern. The first 3 rows are really simple. I just check whether the user has filtered one answer from filter 1 and one answer for filter 2. Just because if more than one row has been filtered, the formula will not work. But if both on filter 1 and filter 2 there is only one row active, we use the many-to-many pattern, but this time we use an additional condition. You see that it's always filter customers calculate greater than 0. It's always the same many-to-many pattern. They are 2 because we have 2 many-to-many pattern. The only difference that makes it a bit more complicated is the additional filter, the additional condition that says count the number of rows in the fact table for only the rows that contains an answer that is equal to filter 2 ID answer on the inner formula and to filter 1 ID answer in the outer formula. These 2 conditions, let's see if it works, this one and this one, are used to force a relationship, to create the relationship we have not created inside the data model, because this relationship and this relationship are non-existent. So this additional condition is simply used to force the usage of a specific relationship that is not present inside the data model. Apart from that, this is just the application of 2 filters on the fact table, and the intersection of both is applied to the customer table. We are counting rows in 2 separate places of the table, and these are 2 different counts, because the first time in the red part we are filtering the customers who have answered consultant and the question job. Once we have filtered these customers, in this context we are going to count the number of customers, to filter the number of, to find the number of customers once we have filtered the ones that have answered 1 million to income, 2 million to income, 100,000 to income. This formula is computed for each cell of our pivot table. Okay? So in each cell we have only one answer, one question. We perform the 2 steps over the fact table and we get the final result. Okay? This might be worth some study at home. But the interesting part is that it works. And it works pretty well. The complexity of the formula is not dependent on the number of answers, but just on the size of the filter table. If you have a lot of different answers to analyze, then it starts to be slow. But a lot of means several thousand. You normally don't have a lot of answers and a lot of questions. You have many customers and many answers. And the formula is not very dependent both on answers and on customers, just on the 2 filter dimension. So it performs pretty well. Of course, you need to have just a few answers, but this is pretty normal. Yep. Should I go back? Yes.
Could you have just basically duplicated the foreign key ID answers to like do ID answers 2 to actually create the join in
Yep. The question is, can you duplicate the ID answer inside the fact table so you can create both kind of relationship? I think you will not get the right result. I'm pretty sure you will not get, because you need to, the fact that the 2 times, when I say that the 2 reference to answer are 2 separate run on the same table, I'm not interested in if you duplicate it, you will filter only the customers It's worth thinking at it.
I'll take your word for it.
Yeah, I think we can speak about it later, because I think I have tried and it didn't work, but
It would be the same, so it doesn't work. Because you need to use just one relationship in one step and the other relationship in the other step.
yeah, but in that case, yes, that's a problem. I mean, the answer is that it shouldn't. I don't think it will work, because you have to use separate relationship in the two formulas, and
You will get two rows, one with the one link to the table and the second row with link to
but if you duplicate the value, you will have only one row linked to both. And if it gets filtered from one, the other filter will not see it.
The problem is that
We are using different answers, so it's not the same answer that answer both job consultant and income 100. There is one answer somewhere that says job consultant, then forget it, and search for another row somewhere else that says income 100. If you duplicate the rows, if you duplicate the answer, then you are searching for a single answer that at the same time says job consultant and income 100. And of course, this row does not exist. It's pretty complicated. I mean, I remember that I have tried it because it comes to mind pretty easy to say, okay, I can duplicate it, and the results were always empty. Understanding it needs a piece of paper and some handwork. Okay? Thus, survey. The most important part is that it can be solved. It's not very easy, but you have the formula, you study it, copy and paste, and adopt it to your necessity. It's very compact. If you have in mind the same scenario in UDM, you need to duplicate the fact table. And the fact table, of course, is the biggest table inside your data model. Duplicating it is not a good idea. In tabular, you do not need to duplicate the fact table, you just need to duplicate the dimension, just for usability purposes, because the users need to have two dimensions where to put the different filters. But the fact table remains only one, because the usage of relationship is inside the formula, it's not inside the data model. That was the reason why in UDM we had to duplicate the fact table. It can handle any number of questions, just add more dimension, more filter dimension, the more complex the formula will become. The interesting topic about this data model is that the fact table is now our bridge table. It's slightly different from the ones we have seen before. Before we had dedicated bridge table, now we have the fact table acting as a bridge. We are setting the relationship in DAX, but at the end, we end up with a data model that can be queried easily using a simple pivot table. Okay? Last data model I want to discuss is basket analysis. This time the scenario is the well-known AdventureWorks database. We have dim product, dim time, dim customer, and the fact internet sales. It's a simple dimensional model, but our customer want to discover, of all the customers who have bought a mountain bike from me, how many of them have never bought a mountain tire tube. Of course, it's interesting to perform such a kind of analysis, because if they are not buying mountain tire tube from me, they are buying somewhere else, and I want to discover what's happening. Answering this simple query in UDM is not very easy. The big problem being the presence of not. I'm interested in the customer who have bought a mountain bike, but they have never bought a mountain tire tube. You can do it in UDM. It's pretty complex. You can solve the problem quite easily using SQL. You can write a very simple query like this one. I'm referencing 2 times fact sales, creating a join, and then I put the filter in the correct place. This is a pretty simple query. nothing really complicated. Any user can write it. But if you take a look at the query plan of this query, you see that we do 2 table scan and then a hash match, and the hash match happens between the fact table. It's not a very good idea to perform a self-join of the fact table of your data warehouse because it's supposedly a quite big one. So SQL is very easy. It's very easy to express the question in SQL, but performances are not very nice. But we have tabular at our hands. So we start with our data model. We can load all this information inside the Power Pivot workbook. And then we have our first problem. We can use the product to filter, for example, mountain tire tube. But we don't have a place where to filter mountain bike. And we want to filter both items. Okay? So we need to add a new dimension that I call product filter so that I can create a slicer on mountain tire tube and a slicer to filter mountain bike. And then I will need to create a formula that computes the value I want. Okay? This is the reason why all this discussion is just to tell you why there is a dimension called product filter, because I need to filter 2 different products in 2 different ways that do not interact each other. And of course, for the same reason of before, I cannot create a relationship between fact internet sales and product filter, because I have only one product key and I cannot create both relationships. I will have one relationship within product, which is the natural one, but no relationship with product filter. Again, I will use DAX to simulate this relationship. Let's have a look at the final result. Oh, sorry. The final result is just here. I have product filter here, where I filter mountain tire tube and patch kit, because I'm interested in people who bought one mountain bike, and I want to know whether they bought mountain tire tubes and or patch kits. And the value that I want to compute are these. Having product is the number of customers who have bought a mountain bike and have bought a mountain tire tube or a patch kit. So they have bought both. Not having product is the number of customers who have bought a mountain bike but have not bought a mountain tire tube or a patch kit. Okay? As you might imagine, computing these values is not very easy. Nevertheless, it can be done in a pretty smooth way if we leverage many-to-many relationships. Let's go back. One last point, just because it will appear in our formula. I'm using a period to time formula. The number 23 is the number of people who have bought a mountain bike any time before 2003 and have bought a patch kit any time before 2003. Okay, so we are not looking just at data for 1 year, but look at the past whenever it happened. This time, this is just to remind you what the various filters do and what we are going to compute. Having product, they bought both. Not having product, bought a bike but no tire. Having product is pretty easy to compute even in UDM. Not having product is the real challenge. But before computing not having product, it's useful to look at how we can compute having product, which is somehow easier. And this time we just look at the formula, because we know how many-to-many works. And this is the formula that computes having product. I don't expect you to understand at first glance, so it might be useful to perform some kind of analysis over it. It's a calculate. Count rows distinct fact sale customer key just means count the number of customers, which is the final result we want to have. That filter means any time before the end of the current period. We selected 2005, so that filter says look at all the time before the end of 2005. And the magic happens for this filter, which is not very easy and might need a bit of attention. Okay? So the first part is very easy. The magic happens only in the filter, which, again, is the many-to-many pattern working. You can see that it's a filter over dim customer. The formula now is somehow more complicated, but at the end we have greater than 0. So it's always the many-to-many pattern, just somehow complicated. Let's look at the filter. We are filtering only the customers where for each of the filtered product, the filtered product is mountain tire tube or patch kit. We have more than one, so we iterate over product filter so that we get whether they bought one or the other. We check if the number of rows in the fact table for that product, we have calculate, we are inside SUMX iterates over product filter, so calculate filters the fact sale. And finally we have is greater than 0. That means we are searching if there is at least one row of sale inside the fact table for that product. Nevertheless, the formula is still complicated by the presence of these two rows. And these two rows are there just because we could not create a relationship between the fact table and the product filter table, and we use these rows to filter the fact table following the relationship with product filter. Okay? We don't have a relationship. Worse, this time we have a relationship with the product. So we have to remove the relationship within product, and this happened due to all fact sales that says consider all the rows. I don't mind if the product filters some. Remove that filter and show me all of them, but then apply a filter based on product filter. And we have to reintroduce the filter on the customer because using all we have removed that filter too. Okay? Again, even this formula might need some study, but it works pretty well, and can be done without changing the data model. You have seen that I have used the customer data model. I haven't performed any kind of ETL. I haven't created any table, just use this data and start working on it. This was the easy formula. Not having product, which is the real challenge, it's identical. The only difference is in the red part. Before we had count rows distinct, fact sales. Now we have count rows, filter, dim customers, blah, blah, blah. We basically count, before we counted the number of customers, now we are counting the number of customers that don't have any sale. So the filter, that filter filters the customer who have bought a mountain bike, and there I check whether they have or have not bought one of the product filter modules. Why I'm showing all these in a session about many-to-many? Because we have a first pattern of many-to-many that is here, and a second pattern, a bigger one, of many-to-many on the same place. Thus, using many-to-many, you can create very complex formulas that compute very complex values on a data model that has not been prepared to answer this kind of formulas. This, I think, is the most important part of the complete session. You do not need to adopt a different data model if you want to answer a specific question. DAX is so powerful that you can create these kind of formulas in a matter of a couple of hours. So the customer asks you, I have this problem, and you say, okay, let me write some DAX. It might look complicated, but believe me, it is not. It's just a matter, it's no longer than a SQL query. Everybody here has written queries of several hundred lines, and after you get used to it, it's easy. DAX is the same. Once you get used to it, it's easy to use. Basket analysis. Let's go to a conclusion. You can model it with many-to-many pattern. This time the fact table is the table that you use as the bridge, and we need to set relationship in DAX. It's very powerful, it's very complex, of course, and the search for missing value is easy as searching for existing ones, something that in UDM is not true. In UDM, searching for missing value is much more complicated. It normally requires you to change the data model. This time, in DAX, you do not have this problem. Finally, some optimization, some features that appear in SQL 2012 and that can help you write in the many-to-many pattern. The first interesting part is that in 2012, you will be able to create many relationships between two tables using the same columns, and this will help clarifying, making formulas that are clearer than before. Because we can create relationship active and non-active, and we have the use relationship function that will tell inside the calculate which one of the existing relationships should be used for that specific calculation. So, our data model in SQL 2012 is a different one. You see the dotted lines between the fact sales and the two tables, product filter and in product. It's exactly identical before, but this time we have the dotted lines. Dotted lines are relationships, but they are inactive. That means they are here, they are simply not working. If we want to use them, we have to activate them. And to activate them, we use a different syntax. This is the same formula as before, written using the null syntax. This is the data model. You see that we have a filter over dim customer, and then two different calculate. One that computes the number of rows in fact sales using the relationship between the fact sales and the product filter. The other one computes the count rows of fact sales using a different relationship between product key and dim product. And we use equal to 0 down, greater than 0 up. This computes not having product in the null. It's much easier. If you compare it with the one I have shown you before, you can understand it, or at least you can have a good feeling of it does something that has to do with basket analysis, while the previous formula was just an exercise, a complex exercise to solve a problem. This is pretty easy to write. Once you get used to the presence of relationship and the fact that you can activate or deactivate relationship at your needs. And if you want to make it more easy, you can keep the relationship within product active, which is the natural relationship between the fact table and the dimension. And in this way, you can further reduce the formula because you do not need to activate the relationship within product in the lower part of the formula. Okay? Thus, basket analysis can be done with SQL 2012. It's not shorter, but it's clearer. It's not faster. It should be faster. I don't have clear numbers here. It should be faster, but I have not seen it just because we are in CTP version, so it's too early to evaluate really speed, but it's much clearer. And I expect an Excel user, after some time, to be able to write such a formula, the version with use relationship, of course. Okay? Last two slides about SQL 2012. Once I have finished my session, I was last week, 2 weeks ago in Brighton, everything was set up, and Casper showed me how to use many-to-many relationships in Denali in SQL 2012. The pattern to use in SQL 2012 is this one, which is different from the one I have shown you before. They do exactly the same calculation, but I feel this to be much harder to understand. It took me several minutes before I got that this calculate computes exactly the same formula as the one I have done with filter over the table. Summarize simply iterates over the bridge table and summarize it using any column that is in the table or in a related one. So summarize will iterate over the bridge table, which is already filtered by the dim customer table, and for each row we'll check only the existing value for ED account, but it will not return a set of ED account inside the bridge table. It will return you a set of ED account in the dim account table. That is the list of ED account in the dim account table that should be made visible to the fact table. And at the end, summarize exactly computes the same value that is computed by what previously was an iteration. The difference is that now the iteration is not explicit, and DAX feels free to push the filter down to the Vertipaq engine, running much faster. I have not tested it seriously. That means I feel that it should be much faster. There are many reasons why it should be faster, and at this moment I trust it. It should be very fast, but I have not tested seriously to give you some correct values. And the last point that I want to show you is that, as I told you, if you have 50 measures, you need to repeat the many-to-many pattern for all the measures. And this is something that you cannot have. You have to do that in DAX. But if you are not interested in using Excel to query your data model, I know that Microsoft says that Excel is the only client that should be used to query our data model, but reporting services is there and might be used to query a data model. Your customer client, your custom client, you build your tool. So you are not interested in using Power Pivot, so you can use DAX and directly query the data model. In such a scenario, you can avoid repeating the many-to-many pattern in all the measures, because you use this pattern that says evaluate. Evaluate means I'm going to ask you to calculate the table, return it to me, please. Then we use calculate table. This complex syntax, add column, cross join, means make a cross join between type and data. It creates a temporary table, and for each rows in the cross join, it computes the two measures that are here. You see that here I have sum of amount, average of amount, but no many-to-many patterns appears inside this formula. Everything works because the many-to-many pattern is this part. And this part, this is the many-to-many pattern. It is outside of the single formulas, but it as a parameter of calculate table. So the formula are computed, these two formulas are computed when the pattern is already active. So at the end, the filter works on both formula at once. And I don't have the need to put the many-to-many pattern inside the inner formulas, because they inherit this from the outer calculate table. Of course, these techniques works only if I'm not tied to Excel, because I can write my personal query. One of the interesting part is that the summarize, the step over the bridge table, happens only once. I might have very complex formulas. I have an iteration over a cross join, so a lot of cells, but only one time the cross join, the iteration over the bridge table happens. So I expect this formula to be much faster than this time. It's not that I expect, I tested it, and it's much faster than repeating the many-to-many pattern in each single formula. That makes higher the number of rows that you can have in the bridge table before stopping using it. Thus, we can finally say that even if there is no support for many-to-many inside the tabular, using DAX, learning DAX, using some advanced DAX, you can leverage many-to-many, and you can create complex formulas, complex data models that runs much faster than multidimensional. We have seen many-to-many relationship, how to handle in tabular, very powerful, and take a look at use relationship summarized in Denali, because they greatly enhance the power, the usability of many-to-many inside formula. This is just to remind you, this is the last slide, to remind you that all this stuff plus much more, because of course in an hour we cannot explain everything, is inside the many-to-many revolution 2.0 that I have finished with Marco, and should be on the site pretty soon, hopefully very soon. Just go to sqlbi.com and from there register, and we will warn you when it's finished. Maybe Friday, okay, but he's Italian too, so who trusts him? Thank you very much.